Alright, so what is the definition of mesh? One more time. Definition of mesh is when the clients themselves transmit the signal to other clients. So there is always in the wireless network, there is generally a service provider, the carrier, AT&T or something like that. And if and then they give the signal a connect to the clients like us. In the fixed wireless, it could be a home. And so, but when the clients connect themselves to other clients, that is called the mesh network. All right, because there is another concept called relays, where the carrier transmits from one tower to their own another tower. And from there it comes to the client. That is not a mesh, even though it is 2-hop. So not everything which is multi-hop is a mesh. All right. So the key thing which distinguishes mesh is actually multi-hop for sure, is that the destination is not the next, it could be more than 1 hop away on the wireless, but that it is done by the clients, not by the service provider. So there is a new standard called 11S. And 11S, because this is client, because your signal is going to other clients, you really need to be secure. So one of the first thing 11S does is it adds security, and the 11 security standard is called 11I, and this one actually adds. Now here's the thing, we are not going to be discussing the security in this class, and the reason is that we have so many things to discuss just in the wireless aspect that we leave the security for the security class. So we have a class on network security in which we discuss the whole security issue, and so 11I, for example, I'm not going to discuss here simply because we don't have the time, and we have other things to discuss which are much more recent and much more relevant. Okay, so 11I. So this one is, now for example, when we discuss 11I, at that time we have to discuss what is a key distribution center and what are the keys and how they are shared and all that. So since we are not going to discuss that, I'm just going to briefly explain that basically the way it works is that everybody has a password or a key that identifies them, and so they share that with the KDC, which is the key distribution center, and then the key distribution center authenticates you, saying that yep, you are the person, you are saying who you are, and so that is the kind of mechanism which is used. Beacons and probe responses to advertise the mesh ID, the routing protocol, the security capabilities, etc. So we know what is a beacon. Beacon is something that is sent by the base station, and probe is what is sent by the subscriber station. So you could send a probe and saying that is there a Wi-Fi available here, and the base station would advertise a beacon saying that Wi-Fi is available here. So one or the other way, and both are not necessary. So for example, most often it's the beacons which tell you what is available, and anybody can listen to those beacons and figure out what is available. But sometimes for security reasons they don't announce the beacons. Alright, so this is one of the options in your own wireless networks. When you set up 802.11, it has an option whether do you want to announce the SSID, and you could say no, I don't want to announce it. In that case, the receiver has to know the SSID, and it will send a probe. So it will, suppose then the receiver knows that it has to look for Wi-Fi, then it will say is Wi-Fi available here, and that's the probe. Alright, and then the base station will respond. So that is a little bit more secure, because when people say what are the networks available, they find blank. They don't see that network on the screen because nothing is being announced. Alright, but it is there, and so you ask for it and you get it. So the distinction between probe and beacons is clear, right? Beacons is announced by the base station, probe is sent by the subscriber station. Alright, so that is the beacons and the probe to advertise mesh ID and so on and so forth. use 6 address schemes to accommodate mesh tunneling. We already had 4 addresses. Now there are 2 more addresses to get from beginning to the end. Includes route discovery, route maintenance, route recovery, and mesh routing. Basically, now every station has to know how to get from A to B. So they need a path. Right? Generally, 11s just talk to the base station, and the base station possibly knows how to get to the next hop. But now everybody has to know the next hop. So everybody does what we call layer 3 operation, but it is all done in layer 2. The routing is done in layer 2. And so there are 2 protocols for layer 2 routings. And actually, not 2 protocols. The 2 protocols are combined to make 1 protocol. There is tree-based routing and AODV routing to combine to make something called hybrid wireless mesh protocol routing, HWMP. Alright, and we will discuss these routing when we come to the layer 3 for wireless. Alright, anything about 11S? 11T is basically for performance. How do you measure the performance of different things? And so in particular, it defines the metrics for data, latency, application, and streaming media. So you can say, well, for video or for data, what is the delay, what is the throughput, how you measure it. So the latency, delay jitter, packet loss, and the probability of admission, all of these things are defined in that. So this is basically a performance standard which defines these metrics so that everybody measures the same way. Otherwise, everybody will measure a different way, and when you get the equipment from 2 different vendors, you do not know how to compare this number with that number. So because if you, and there is a trade-off here, because if you increase the path loss, if you allow 10% loss, then throughput goes up, if you call that throughput. So the question is, what is throughput? And then fast BSS transition, receiver sensitivity, association performance, all of these things are measured in that one. So association performance is how long does it take to get associated with a base station. Before you can get associated with a base station, you have to send some things. You have to first authenticate, and then negotiate other parameters. All that takes time. So that is also measured. Receiver sensitivity, if the receiver is very sensitive, then it can get much more throughput at a longer distance. So that is affecting the throughput and all that. So all of this discussion about the performance is in that standard. So if you ever need to worry about the performance, you go to that standard 11T. By the way, these letters, some are small and some are big. So 11S, S is little, 11T, T is big. And there is a notation. In all of the IEEE standards, actually, I'm not sure about all the standards, the 802 standards for sure, they follow this, that the little ones are extensions, are enhancements to big ones. So to big ones, yeah. So, for example, little b is an extension to 11, and what they do is, once the 11b is done, that whole document will be merged into 11, and the new 11 document will come out. So there is no standard finally at the end called 11b, because 11b is an enhancement to 11, and it gets merged into 11, right? Whereas the big letters, these standards stay on their own. They are not an enhancement. So this 11T is a standard on performance which will remain separate. So there is another one, for example, 802.1 capital Q, 1 capital D. Those are the examples of standards that stay on their own. Everything which is little goes away. Yeah.
So where does N go?
N is a little.
So where does it go?
11. So basically, after 802.11 N came out, they developed a new version of 802.11-2009 or something that has all the 11N. All right. Now, if you really read the 11N standard when it was being developed, it doesn't have the beginning or the end. It just says change the paragraph number 5 to that, change paragraph number 7 to that. So it just changes. All right. So those little ones are extensions, are enhancements, and they are generally defined as a diff kind of thing, or difference. They just tell you what to change in what paragraph. So they even refer to the section numbers of the original standard. They might even add new chapters. So add chapter 52. But all that will be after the standard is finished, that will be added to the base standard, and that extension will go away. All right. So for example, if you go and try to find an 11B standard, you won't find it today really, because 11B has been merged to 1199, whatever here. So a new version of 11 keeps coming out every time little one is done. Clear? All right. 11T. Now we have 11U. And U is little. So this is interworking with external networks. All right. So basically, what happens is you might have an access point, say for example at the airport, and it might supply services with AT&T, Verizon, same access point. One access point providing services for many different carriers. In that case, when you come in, you say, well, I'm an AT&T customer and then I want to go to AT&T, right? So you have to be connected to the right provider, and that is what this standard basically provides. And it might be very simple, small standard. Anyway, it says 11U, so it's an extension which says that these are the two new messages we need. This is a new field we need. This says connect me to provider, and that's it. So those messages are defined in this standard. So allows network selection, checks if the network supports a particular carrier, right? Allows a multiple credential to select a proper one. So now you could be selected, you could have, for example, you could say, well, I can select a T-Mobile and Verizon, one of the two. So you have multiple credentials. One access point can support multiple SSPNs, which is a carrier or service provider. Clients can determine interworking services before association. And before you associate, you can check that everything is fine, and then an emergency 911 calls. And this allows you to basically make emergency calls. So basically there must be some way to say that this has to go to the 911. Okay, everybody knows what is 9/11? September 11th? No. Well, 9/11 for those of you know what is 9/11? Okay, all right, good. So that's the emergency number you dial if you are in an emergency, right? Police number. And many of the cellular companies initially did not provide those services because they were not connected. Now they are required by law not only to be connected to the 911 but also to tell your position. So when you make a call to 911, the operator on the other end knows exactly which location you are calling from, so they can send you help. Alright, so that is 11U. 11W is management frame protection. So 11 had big security holes, many security problems, but one of the big problems was that the management frames were not protected. So what is a management frame? Such as disassociate, deauthenticate, or broadcast and multicast, none of these things were protected. So when you hear that Boofy is available, you don't really know whether Boofy is available because it is not protected. There is no way to authenticate that this is Boofy. Alright. In fact, what you could do is, one of the attacks was that you could disassociate, means you could say, well, I am Jain and I want to disassociate now with you. So I'm not don't send me any more packets. So your connection will be disconnected by somebody else. All right. So this standard fixes that issue. And so it provides data integrity, data authentication, replay protection, and data confidentiality. What is data integrity? Data integrity basically means that nobody can change your data. So if you send something, nobody can change. You have a question?
Well, yeah. Has W actually been rolled into 802.1? Because I know a lot of vendors actually rely on not being able to authenticate POF packets for like road.
Yeah, okay. So let me see the standards. Sorry. Let me see the status of this 11W. Okay, 11UV. Wow, W is even missing from my list. So I don't know the status of it, whether it has been finished and rolled into or not finished. I don't have the status. I will have to check. Sorry. All right. Yeah, so that's the problem. You are saying that the deassociation attack still exists.
Well, and a lot of vendors rely on that for rogue AP detection, so that like the wireless access points around Washington, they can key off your little links this router or whatever.
Yeah.
So that it makes you disconnect. From
Yeah.
it, and you can only associate it to wash use. I was wondering if vendors have a problem with this.
Yeah, so there are two things which happen. First of all, if W becomes a standard, then it will take 1 or 2 years before it will appear as a product, because it has to go through the Wi-Fi. Everybody knows what is Wi-Fi, right? Wi-Fi is the organization. So it has to go through that organization. Once they say, yeah, everybody has to implement it this way, then it will be implemented. And so there is a delay. And after it is implemented, then there are older standards, older products which do not go away. So you cannot even do, for example, at my home, I have some older pre-I devices and some post-I devices. 11I is the security standard. I can't use really post-I because there is one device which will not speak, and I need to speak to that. Right? You cannot just throw away one device simply because it doesn't speak 11I. It's a $300 camera, right? So everything else is speaking pre-I, which means it is not protected. I mean, so that's the kind of thing we run into even any other place, that they might have an expensive piece of equipment which still needs to work, and it still speaks the old ways. Okay. All right. So I was defining data integrity, data authenticity. Okay. Integrity simply means you cannot change the data. Authenticity means it is from the person he is saying it is from. So you cannot just manufacture and say, well, and this is coming from Jain or somebody else, right? Replay protection. So nobody can everybody can hear our messages, but they cannot replay it. They cannot send it again and be meaningful. Confidentiality means they cannot even read it. So when you send something, it is encrypted. So this is encryption, this is CRC, this is basically authentication, and this means there is some time thing over there so that you cannot replay it later on. Without 11W, attackers can forge disassociation. This was one of the common attacks, is that you could just send a message saying that, okay, I want to go, and then you are gone. Somebody else could say and for you, and then you are gone. Broadcast integrity protection, and they use some standards called AES 128 CMAC. The whole thing is a standard name. So that is the encryption standard with which they protect the broadcast. So when you get a broadcast, you know that it is coming from a station, and you can authenticate that. Provides replay protection and forgery protection against insider attacks. So what is an insider attack? Basically, generally the attacks are coming from the outside people, but if you are an employee who wants to do something bad, they could send out something, right? So those are difficult to crack because they are coming from inside. So this has something which protects you from replay and forgery from inside. So only the one device that is authenticated, or only people who are authenticated can do it. People who are not authenticated cannot forge it. So anyway, basically 11W is the next level of security after I. 11Y is the contention based protocol. So we already have contention based protocol. The 11 is contention based protocol. All it does is this one opens a new bandwidth, new range. So we have 2.4 and 5 point something. So in middle, FCC has given 3.6 to 3.7. There is about 500 megahertz there. No, 50 megahertz there. 3.65 to 3.70. 50 megahertz. 50 megahertz. The thing about this 50 megahertz is that you cannot use it if the people who have licensed that are using it. So this is kind of conditional use for free. If they are not using it, then you can use it. It's like, this is not actually used for television station, but this is used for FSS and radio location services. FSS, fire security. It could be fire services. Okay. So the thing about the fire services and the radio location services trying to find who is where. These things are not always used. I mean, people have, the fire services have the location in that band, but they don't always use it because they're not always active. So this band can be used when they're not active. So, and in that band, you can use a little bit more power than other devices. You can use 25 watt at the base station and 1 watt at the mobile clients, and that gives you longer range. So basically, you can go much farther than 11, standard 11. Now, having said all this, 11 by, I don't know whether it will really come through, because I mean, it does require extra hardware in some sense, because now you're covering another band. I mean, you cannot work in this band all the time. You are working mostly in 2.4 or 5 point something, but if you find 3 point something available, you use it, and when it is not available, you go back to one of those other bands. Right? So it is at least dual band stuff. Final thing we want to talk about 11 is this CAP, BAP, which was on the list of projects to do. So this problem we have already indicated, a large number of access points people have, and they need to configure routing, security, forwarding. There are so many parameters, and these things are remotely basically located. They are not located in one place, and they are generally located in the ceilings, inside the ceilings, and so on and so forth. So there is a group in IETF. What is IETF? What is IETF? Have you heard of IETF before? You have heard of. Anybody else has heard of IETF before? Okay. If you have not heard something, please ask right away, because if you don't ask, I somehow assume that you know it, and we know it for by heart, because we work with IETF morning and evening. So IETF is the Internet Engineering Task Force. Internet Engineering Task Force. This is the standards body for all the internet protocols. So when you talk about IP, TCP, RTP, any IP protocols, they do it. Everything layer 3 and up, they do it. And so they meet every 3-4 months, and we go to those meetings, and during in between 4 months we have lots of emails on each group. They have lots of groups working on different things. So they have a group called CAP-BAP. CAP-BAP is configuration of access points, wireless access point, something like that. In the project list, we had the complete extension. Control and provisioning of wireless access point. Control and provisioning of wireless access point. And they started back in 2004 or so, 2005, they came out with the first RFC. So IETF writes the result standards which are called RFCs. And so the first RFC came out in 2005, and they're continuing all the way up to 2009. And so if someone were to take that project, what they will do is they will read all these RFCs, And there are some RFCs which are still in the making, which are called internet drafts. So they will, and all those are available at IEDF website. So you take the RFCs and you take the internet drafts, and then you write a summary, basically paper on that one. All right. So is working on a common methodology for configuration and for remote provisioning. So basically you could take anybody's access point and you could configure it sitting at your office. That's the idea. Everybody speaks the same configuration language. So this is more of a management thing than anything else. All right, that brings us to the end of this part of the lecture. So what we have done this part is, first of all, we learned that there are MAC frames have 4 addresses. Now I don't know if, how many of you remember what are those 4 addresses. Let me remind you some things here. So there are 4 addresses. There was a source and destination, SA and DA, and there were 2 more. Anybody remembers what those 2 were? Receiving. So there is a transmitter and the receiver. So the transmitter and the receiver don't have to be the source and the destination. Source could be somewhere there. Packet came to me, I am the transmitter. I am sending it to you, you are the receiver, and then it is destined for somebody else on the other side. Right? So that is 4 addresses. 11E was the standard that provided better QoS. How many classes does it 11E provide? Anybody remember that? There were how many queues? 4 queues. And how did it do that? What was done to SIFs, diffs and PIFs? Anybody remember that? Basically we had 4 sets of numbers. Yeah, depending on the priority, you have different waiting period and different transmission period. That is 11E. 11N improves the throughput. And how does it improve the throughput? By 2 things. Mainly, I had the list of 10 things, by the way, but the 2 main top things are MIMO and channel bonding. What is MIMO? Multiple antennas, right? And what is channel bonding? Yeah, so you, instead of having 20 megahertz, each channel is 20 megahertz, you use 2 of them, 40 megahertz. Then there are activities going on vehicular communication, fast handover, mesh networks, and so on and so forth, right? So those are the things we talked about. All right, luckily there is no homework, so you guys are all free. That's not good. Now here's the thing though. You should go to the library and read, please, because we have reserved 8 books there, and they have, every book should have something about 11. So that is how you will, basically you will get into this, and also get used to doing this dB stuff, because the more you do, the more you get used to the right things. So how to convert from log to dBs, and from watts to dBs, and so on and so forth. Some more work on that one, all right? Okay, so I finished this one, and I move on to the next chapter. Well, we have 8 minutes left. Any question about anything? And I am running behind, so I must actually probably move on. So we'll move on to this one.